Okay, Illibri is working on a proof to show that a parallelogram with vertices at A, 0, 0, B at 3, 4, and point C located at 11, 2, and point D at 8, negative 6 is a rectangle. She already knows the figure is a parallelogram. Her work is shown here, but a few steps are missing. Read her proof carefully and then follow the instructions. So this is how I would go through this, and I would first just scan to where the first blank is and go back to the statement. So it says distance of BD is equal to the square root of 125. What is the reason for that? Well, how did she find that distance? What of BD was equal to 125? She had to use the distance formula. So I'm looking for a distance formula. And then again, blank 2 is blank, but the reason is a distance formula. So I'm going to be looking for a distance, and I'm scanning through this to give myself an idea of what a distance is. And if you notice in statement 6, it has segment AC is congruent to segment BD. We already had the distance of BD, so if they're going to be saying that these two are congruent, segment AC has to appear up here. Notice though that when you're using the distance formula, it doesn't appear with the segment sign above it. It is just the 2 points. So blank 2 is going to be the distance of AC. So distance of AC is equal to a square root of 125. Blank 3 and blank 4 are both the statements and the reasons. So I'm going to ask myself, well, if we had AC is equal to the square root of 125 right here, what does this step have to be so that I can end up with congruence from segment AC is congruent to segment BD? We would have to have that some form that AC, the distance of AC, has to equal the distance of BD. Which it is because they're both equal to the square root of 125. So statement 3, I'm looking for something that has distance of AC is equal to the distance of BD. So distance of AC is equal to the distance of BD. Now blank 4, how do we know that? It is a property that I hope you have become familiar with already. It's called the transitive property of equality because they both equaled square root of 125. So then they just connected the first statements instead of listing out square root of 125. So it's like they just jumped that middle step. So it is the transitive property. And then parallelogram ABCD is a rectangle by blank 5. Well, what is segment AC and segment BD representing in this parallelogram? So if I were just to like draw this out, and I'm just drawing it out that I know it's a parallelogram. A, B, C, D. If I notice A to C is a diagonal, so is B to D. So they're proving that the diagonals are congruent, which is one method to prove that it is a rectangle. So they're proving that a parallelogram is a rectangle if and only if its diagonals are congruent. A parallelogram, yes, it was talking about its diagonals. So that's how I would use the knowledge I had and referencing back to the proof to answer this question. I hope that helps.